Dilutions. What are dilutions? Well, you learned in general chemistry that in order to dilute something, you're taking something that is more concentrated and then diluting it or making it less dilute. But I just used the name in the definition. What does that mean? You've got some total volume with a large number of moles of an atom or a compound in it, and then you're transferring some of those moles of that substance over to another liquid that now you have less moles per given area of space. Okay, so you're diluting it. If your tea is too sweet, you're gonna dilute it, all right? So dilution is an important concept. Now, we don't really give you the equation in general chemistry of the dilution equation, but it is M1V1 equals M2V2. And the idea is you've got some initial molarity, M1, times the amount of that you just take from it. So not how much did you have 5 gallons of sweet tea. It's I diluted 1 milliliter of my tea to a total new volume of 10. And so your new volume, your V2 is your new volume. So your V1 is the amount you took from it, and then your V2 is your total new volume that you diluted it to. So what I'm holding here is a volumetric flask. This is a 100 milliliter volumetric flask. So if I were to fill this with just maybe 1 milliliter of a stock solution and put it in here and then dilute it to the line, that would mean my V2 is 100 milliliters, and then my 1 milliliter that I put in here would be my V1. Okay? My M1 is the concentration that started out with. Your M2 is your new concentration. And so this equation helps us figure out, hey, how did I dilute stuff and why? When using a vol flask, you do have to remember to dilute it to the line. If you dilute to the line, that's exactly 100 milliliters. Well, 100 milliliters plus or minus, in this case, 0.08, and we'll learn about that later. But the idea is if you go over it, you don't know your volume. If you go under it, you don't know your volume. So you have to dilute it to the line or you have to redo it. But why are dilutions such a big deal in quant? Well, we dilute everything, it seems like. It seems like we do a million dilutions. So figuring out which M's go with which V's is crucial, okay? They have to describe the same substance. So in my example I just gave you with the vol flask, it was the 100 milliliters went with the concentration of that 100 milliliters. The 1 milliliter went with the concentration that it started out with. And so we're gonna do lots of dilutions in here because we're doing calibrations curves, we're doing lots of just random stock solutions that we're making, and then we're analyzing them. And so really grasping your head around this idea of dilutions is essential. Another thing to think about as we're looking at dilutions is really what is a concentration. And remember, concentration is just the amount per a unit volume. So it can be moles per liter, it can be grams per milliliter, but just thinking about what is it and what can you learn from it. Or even mass percent. Mass percent is pretty important. We're going to do a lab possibly where you've got like hydrochloric acid, it's like 37%. Well, that's just a percentage, okay? That's telling you that this percentage of this concentrated solution is hydrochloric acid and the rest is going to be water. All right. You could look at the board, and behind one of my little hidden cabinets above the teacher's desk, it tells you what the molarity is of that concentrated 37% solution. Or you could do the math and work backwards, but just keeping in mind that you're looking at fractions, you're looking at percentages. It's all just a mathematical relationship that lets you determine how much you have per some amount of volume. And so when you're thinking about concentrations and dilutions, just keep that in mind. Don't overthink it, but do make sure you're very consistent and you get used to kind of a systematic way of approaching dilutions and concentrations.